All right. Hi, everyone. Thank you for coming. In this talk, I'm going to talk about Nomad as an alternative for Kubernetes. First of all, who knows what virtual machines are? Okay, perfect. Who knows what containers are? Perfect. I can skip the whole explanation. So, who am I? I'm Christoph. You can find me everywhere online with my handle Karamato0. I'm an open source consultant at Inuit, so we provide open source solutions for companies or help them with building infrastructure, developing websites, and other things, all based on open source technology. For the past 4 years, I've been doing consultancy at an IP over satellite communications company, helping them to build their next gen. You know, it's always the next gen infrastructure based on containers using OpenShift instead of OpenStack to be able to scale. Of course, I do Kubernetes for money, and I do Nomad for fun, and I'll hope to show you why and get you also motivated to, if you're looking for container orchestration, to consider Nomad as an alternative for Kubernetes, especially if you don't have that many requirements, shall we say. So first of all, what is Nomad? So Nomad is a container orchestrator. But it does a little bit more than just purely containers, because it has support for other components. So if you compare it to Kubernetes, it's much smaller. It's a single Golang binary, which does everything. You can deploy and manage and scale containers for your environment. Well, obviously. You can deploy containers or other workloads on-prem, at the edge, any cloud platform. It has multi-region support, multi-data support, and of course you can also use it on-prem, so on bare metal, or at home, or whatever. It scales very well on a single node. So Nomad is a product from HashiCorp. You may know some of their other products, such as Vault for secret management, Vagrant for local development, Terraform, and some other cool technologies. So that fits very nicely into their ecosystem. So it's you don't need to use all the technology at the same time. You can use them independently of each other. However, they do tie in very nicely once you combine them. Scales to 1,000 nodes on the blog somewhere of HashiCorp. They have a very nice use case of, hey, let's try to force the system as much as possible, see how much we can squeeze out of Nomad, and they reach very nice numbers and results for that. So as I mentioned, supports non-containerized workloads, so you can run virtual machines on it using KMU. You can run Java jar files on it, or raw executions, for example. So it's usually an overview looks a little bit like this. So for example, as a developer, you can write jobs which are then submitted to Nomad, and then depending on the scheduling, etc., it can be your jobs can be scheduled either on the cloud or on-prem or whatever. As an operator, you can write policies to which developers need to adhere to have their jobs be accepted or not accepted, depending on, those can be access controls, those can be resource restrictions, those kind of things. So what you typically would expect from something that you'd use in an enterprise, for example. So here's another example of things that you can run it. So if you compare this to Kubernetes, for example, Kubernetes really is a big box of Lego blocks and different components. Probably people familiar with Kubernetes have seen this before. So this is the CNCF Cloud Native Landscape. So what is this? This is an example of the box of Legos of thousands of components that you can pick to use in your Kubernetes cluster, depending on the various functions. If you want to have, let's see, platform level tools, there's 1,000 choices here. How you want to do networking, there's 1,000 choices there. How you want to do your storage, there's 1,000 projects there listed there that you can use. So when you're working with Kubernetes, one of the challenges is like there's so many choices, so many different projects with so many different states of maturity and lifetime. So that's also very important because one of the stressful things about Kubernetes is picking what you want to use and hoping that it'll stick around long enough for a while. With Nomad, it's just, hey, you want to do a certain thing. There's only one way. You want to do this. There's only one way. Well, or a couple of ways. So it really narrows down the choice to making a simple choice. So, yeah, with Kubernetes, this is not a Kubernetes talk, but there's like the point I want to make is that there's various different components responsible for various different things. With Nomad, you just have, well, technically speaking, two components. You have the node, well, it needs to run on somewhere, something, bare metal, a virtual machine or something like that. And then you have the agent. So the agent is just the Nomad binary running in daemon mode, so a long-running process. And as an agent, it has two modes of operations. It can run as a server. So in server mode, that means that it participates to the quorum, the cluster communication, so communicating with other servers to coordinate what kinds of jobs are run, those kind of things. And a client mode is essentially, hey, I'm running on a node. This is what is available on the node, and it actually runs the things. But does not participate in the quorum or election or those kind of things as part of the cluster. Requirements, very, very low. Yeah, this is just to give you a small idea of requirements, so it's not that much. The nice thing is that it can easily run on a laptop for development purposes, for testing out things, but it can be as scalable as you want. So let's take a look at some of the components of Nomad. So the most important main thing is jobs. So a job defines the kind of workload that needs to be scheduled, where if your job needs to be aware of where it needs to run, as in which data center, or if it needs to just ensure that it's run once somewhere, or if you want that job to be run on every single node. So that can be interesting for monitoring, for backups, those kind of things. Yeah, so just as infrastructure as code, that's a bit the principle behind it. You define what you want to run in a state, a kind of manifest, and the cluster will make sure that your desired state is, well, the state of the system is as it has been described. The job specification, so just like with many other tools built by HashiCorp, it uses the HCL configuration format. I'll give you an example of how this looks like. So this is an example of how at home I'm running an instance of iPerf on every node, so that I can, test the bandwidth between my machine or whatever with any of the servers. It's confined to my home data center. Now at home I just have my home data center, but I could easily have my home data center at home and have, for example, a cloud instance somewhere, so I can also be selective of where this runs on. I define a group, more explanation on that later. I define some networking stuff, and I just describe a task which uses Docker as a driver, and then you can see some things that might look familiar, like the image I want, the port, the command, environment, and resource constriction. So this is how usually a job specification looks like. So now let's talk about driver. A driver is something that enables Nomad to execute something. So, for example, Docker is a driver, Podman is a driver. Now, Nomad by itself does not provide that functionality. It needs to be available ahead of time on a node. So that allows you to, mix and match different machines, and not all your machines need to know how to run containers with Docker or Podman. You can have a couple for containers, or you can have a couple of machines which have QEMU for running virtual machines, for example. So the drivers give the capabilities to Nomad. Tasks are, a set of tasks use those drivers in order to run, certain things, shall we say. We have a task group, so this helps with collocating your tasks. So you can have different tasks within a group. The group takes care of running these tasks on the same node. So why would you have different tasks? So let's say, for example, you have an application that needs to have a database script run before the application runs to do things. You can have those things in a separate task, and you can have your main application start in another task. And because they're on the same group, those will run on the same nodes. Or for example, if you have an application that needs Redis for caching or something like that, it's interesting to have those things run on the same machine for performance reasons or something like that. So here is a small example of how you would do that with, it's the example that I gave. We have a constraint which, hey, these two tasks, a server task and a cache task, those need to be run together on the same node, and this node must be of a type AMD64, for example. So when you submit this job to Nomad, there's a couple of things that happen in between. So first, it's evaluated. So the evaluation means that Nomad will have a look at what actions are needed to run this job. Or if you already have an existing job, we'll just look at, hey, are there differences between these, and then take action if necessary. And then you have an allocation, and the allocation is the mapping of your job on a particular node. So it's kind of like an instantiation of your job linked to a specific node. So this is a little bit the rephrasing of what I said. So submit the job gets evaluated, and then the job gets allocated, and the client runs the job. So from an architectural point of view, you can define multiple data centers in which your jobs can run. Of course, there's a quorum system. It's based on Raft, if you want to look that up later. And it also has the concept of regions. So if you wanted to run Nomad in production, you typically use an uneven amount of nodes. So in this case, you could have 3 servers running the Nomad agent in server mode. So that means that they take care of the clustering, they do the quorum stuff, etc., and then have 3 separate clients. Now, however, the difference between a server and a client is just a configuration line. That means that if you want, the really nice thing about Nomad is that you can start as small as possible, one single machine running both as server as client. So that means that you can have, servers that also run payloads. Like in my case at home, I use this at home. It's a lot cheaper to have machines doing the same multiple things at the same time. But if I ever wanted to scale out or something like that, I can, separate my servers from my clients. Multi-region it has also a multi-regional architecture, so that means that you can say, as I said, you can have your cluster spread over multiple data centers, and only the servers are going to handle, the federation essentially, if you want to call it like that. And the nice thing is it's very pluggable. It also has an ACL system, so you can enable encryption, those kind of things afterwards. it's really easy to start from, you know, prototyping, playing around with it, to then build up to something a little bit more enterprise ready, shall we say, or more secure. So that's how does Nomad compare to Kubernetes? So there are two different products. Nomad does not replace Kubernetes, because Kubernetes does have, well, it's the industry standard, shall we say. Kubernetes does provide very advanced features. The thing is, not all companies, or not everyone needs all that complexity. Because if you go look at presentations of Kubernetes, then they always show the same demo. Oh, look how easy it is to deploy an Nginx reverse proxy in a pod. And then like, oh, this is fantastic, this is easy. Until you try it yourself, and then you need to think about, oh, this is a lot of work to actually get something to work decently, while Nomad simplifies that. It's not entirely a replacement, because Nomad can also be run next to Kubernetes. So both products have their merits, shall we say. Yeah. So now, where does Nomad fall short? If you compare it with Kubernetes, there are of course certain things, as I said, that Kubernetes has that Nomad doesn't do, like ingress controllers. Let's see. Yeah, of course, in Kubernetes, as I showed you the picture of the CNCF landscape, Kubernetes essentially has many different building blocks. So in the sense, there's a lack of maturity with regards to that. But you know, if you need something simple, it's not that bad. So here I have a small comparison of terminologies. So they align more or less in this sense. So I'm going to show you a bit of course I use Nomad at home. This is my humble network rack. So at the time I was usually at home, I used to run everything in containers. So I have different machines independently running Docker, and then I run my things at home there. However, at some point I asked myself, hey, I really want my DNS to be high available. And at a certain point I bit the bullet, like, I need clustering at home. I really need that for high availability. So that I can tinker with the network and not disrupt my girlfriend watching her series without screaming at me if it goes down. So I was thinking about looking into Kubernetes, but then very quickly I realized, shit, this gets complicated way fast. While I just wanted something that looks like my Docker setup, but with the clustering part on top, that is not Docker Swarm. So Nomad also has you can use Nomad on different ways. Of course, it has an API. It's API driven. So if you want, you can extract your information from the API directly or interact with it directly. Use a command line, but it also has a UI where you can also submit your jobs or have a look around. So this is the overview of jobs. So at home, what I use, Redis, Scrutiny for monitoring the disks, MySQL server, a Postgres server, Prometheus, Grafana, blah, 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 etc. Then you have also an overview of the servers. Of course, a server needs a leader. So that's why one of them is true and the rest is false. Curiously also, the clients are the same as the servers, so that means that all my servers and clients, I'm running the client, I'm running Nomad on all these nodes, both as a client and a server, to make the most out of the hardware that I have. And then we have an overview of the topology. So here you can see the various jobs that are running in my cluster based on where they're running, how much memory I allocated to them, and how much CPU I also allocated to the various tasks. You also see a very fancy line between all those things. So in this case, this is the node exporter job. So node exporter is part of Prometheus for monitoring, collecting metrics of various sorts. So what I opted to do here is, for example, hey, I'm running one instance of Prometheus, doesn't matter where it runs, but I can also make a node exporter job of type system, which means that the cluster will guarantee that it will run one instance of a node exporter on all of my clients. And then with some magic to have them point to, it's Prometheus that collects the metrics from all the node exporters. Now, there's also not only container orchestration here, there's also service discovery. Nomad has built-in one, but it can also use Consul, which is also a product from HashiCorp to do this service discovery kind of thing. So I can also tell it to, hey, Prometheus, search for all node exporters that you can find in Consul, and that's how Prometheus can explore and discover these new nodes and scrape them for collecting metrics. So yeah, that's in short my presentation on Nomad. So what I actually also use, so another reason why I chose to use Nomad is because when I started to think about how I was going to do storage, in Kubernetes, very often or popular choice is to use Rook, which is actually Ceph. But Ceph was a little bit, a bit too overkill for me to use. So I decided to use GlusterFS. So what I essentially do is, I don't know if, maybe I should use the pointer. So what I usually do is on all these machines, they also run GlusterFS with a shared network, volume, shall we say, and all my applications running inside of Nomad, they write their data onto the shared file system. Yeah.
In your picture, there's 4 machines,
yeah.
The link centers or whatever they are.
Yeah.
But in your
yes.
dashboard, there's 5 machines.
I have another rack here, and I have another one here, which I'm actually, it's not part of. So I have a Nomad 6 node, but I'm not. It's not part of the cluster itself because I'm guinea pig. Exactly. So what I'm actually also doing is I use Terraform to deploy my. So I use Ansible. I use Ansible to manage the OS layer of my servers here. So I install I configure the firewall. I install Nomad. I install Consul. I install Gluster. I ensure that my user is on there. I ensure that Docker is installed, those kind of things. And then I leverage Terraform to deploy my applications onto Nomad. So thank you for asking that, because I actually didn't think about it. However, I was thinking about it, but I didn't have my, let's see if I can show you. I had my editor open for this. I hope this is readable. So yeah, I just maintain a small, this is not useful that it's like this. Let me change, let me just mirror my screen, then it's a lot easier for me to follow what I'm showing you. That's a free light show. Oh, yeah, there we go. I essentially have 2 folders. I have an Ansible one. So let's look at my inventory. So here is this readable actually? Okay, perfect. So here I just define, I have 2 roles for now. I have a server clients group. So those are the machines that function both as a server as a client. So that's 1 to 4. And then I have 2 machines which purely work as clients, so they do not participate in the cluster communication. So Nomad 5 and 6. And then I have, let's look at, I think it's, So then basically I say, okay, look, all my server clients kind of machines, they need to have a common configuration. So that's firewalling, user management, and other OS settings. Install Docker, manage Nomad with console, and ensure that Gluster FS is on there. And then my essentially it looks the same, but with if you know Ansible, it's you can choose the options here. So this is what I use to manage the OS layer. Then I use Terraform to actually manage my jobs on my cluster. So here I have I have a Nomad provider, so this is how I tell Terraform to connect to either one of my servers to which to talk to the API. I have some configuration that I changed. So this is an interesting one, scheduler algorithm spread. Why? Because the default option in the Nomad scheduler is to use bin packing. So that means that it's going to try to cram as many jobs as possible onto a single machine, which is nice for saving space or stuff like that, but not very much for high availability. So I changed the default schedule algorithm to use spread. So that means that every time it creates a new job or it needs to move something, it spreads them all over my different clients so that they are more or less evenly used, something like that. And this is how I just define my resources. So I have an Edgard resource, alert manager, authentic, Bitwarden, my blog, home assistant here, for example. Let's take the home assistant one. So it's an ACL. So what do we have here? The region is global, so that means that even if I have, it's global. We'll only keep this running in my home data center. Well, that's why it makes sense. Type is a service, so type is the service type is just normal. It's just run one job. Another type would be system, and system means that it's the equivalent. It's the Kubernetes equivalent of using a daemon set. So ensure that you're running this job on every client. So here's my group, count 1. I only have one task, home assistant. This is the image, network mode, MAC VLAN. So that means that from a point of view of the network, it's as if my container was flat, was just on my network, pingable, reachable, as if it was a VM or a machine directly plugged into my network. And then I use this mount point to read and write all its data from this shared mount point, which is on every node. Now, this is useful, but in my setup, this is the Achilles heel of the setup, meaning that this assumes that my distributed network is fast enough to sync everywhere. By the time, so if one of these containers moves to run to somewhere else, the hope is, or the assumption is, that the storage was synced fast enough before the job is started, because otherwise you might risk getting corrupted data or something like that. So that's a little bit the downside of my setup. I also run Tailscale here. Also nothing special. For example, an application that needs to connect to the database. For example, Netbox, which is a useful thing to if you have a data center at home or something and you want something to have an inventory or manage an inventory of your servers or network equipment. This is very handy. So Netbox uses database and Redis. And what I want is that Netbox will only start when it's able to reach Redis. So what I do here, so I have a group. So that means that everything within here will be co-located on the same node. I have one task called wait for Redis. I tell it that it has a pre-start lifecycle hook. So that means that this task will start before this one or any other task. And the only responsibility of this task is to, in a loop, try to use Netcat to see if it's able to reach Redis. If it fails, it's just going to start in a loop, and it will be the driver is exec, so that means that this netcat command will run directly on the host.
That's nice, right? I end up doing things like this or waiting for Postgres to be available.
Yeah. So as you see, I made a silly mistake. I did put this logic in here for Redis, but not for the database. But yeah. Yep. Okay, that would be an.
Split it up, like
yeah.
We end up with like try to.
Exactly. Yes.
That into your main container.
Yeah.
Doesn't really want.
So you create your own dependency.
You can create your own dependencies. Yeah. Let's see. Scrutiny. Something else that's interesting to show.
The bit warden.
The bit warden is as simple as any other application. So. Let's see. Yeah, I also have it open here. I do have some time for showing some more live things. So AdGuard, for example, is my it's like Pi-hole for for DNS and blocking advertisements and those kind of things. So this is the job. I can see here how many allocations are running. These are the amount of allocations that are complete. So that could be, if I change the configuration to the job, it gets restarted, so then it becomes complete. Let's see, recent allocations 10 hours ago. Here I can get an idea of how much resources I allocated to it and it's actually using. Yeah?
You were now showing the resources on the dashboard, but I saw in your configuration files that you limit the resources. Let's say I saw 500 megahertz, a gigabyte of memory. This can be distributed over Nomad. You say, like, for example, okay, node 1 to 4, they can use half a CPU and 1 gigabyte of memory. But for example, on node 5 and 6, they can use more. Is that something you
This I don't know. I haven't played around with it. I'm not sure if that's...
For scalability reasons, I thought,
maybe if...
Or you can argument
I think you could probably be creative with the metadata or the constraints. I'm not 100% sure. Like, if node blah blah blah, then I'm not 100% sure.
Yeah, because in Kubernetes I know how, but
yeah. Let's see. Yeah, from here you can also have access to the logs. Let's see, definition. So this is a little bit, this is not just your job spec, but it's blown out or expanded with all the other hidden attributes that Nomad adds to it. So here you see tasks, mount point, those kind of things. So you can go a little bit into detail of what's in here. Versions, if you say like, oh, I deployed, there was a mistake in my job spec. You can also revert from here, or the command line, allocations, evaluation,
What's the cost of this application?
Free. It's
free
open source.
For home or free for business?
It's open source.
It's okay.
So Nomad just like
pretty. Is it GPL licensed or?
I don't remember the license, but I think they so the way that HashiCorp traditionally works is that it's open source. They do offer, they do offer some enterprisey features, but usually after some amount of time, those features then become open sourced or become freely available.
And how are the communities around Nomad? Like, so for example, if you want to look online for support for Pi-hole or AdGuard, communities on the
You're probably not going to find it that much. Because of course, Kubernetes is the industry standard, shall we say. Nomad can be seen a little bit as a disruptor, in the sense that companies are kind of realizing that Kubernetes is probably overkill. It's especially for their thing, and while Nomad does provide all the features of cluster that you would like to have from a clustering system, with less burden, shall we say. So it's very, let's say, it's very easy. It's very easy to, if you're starting on a project, you have no idea if it's going to explode or become popular or whatever. It's very trivial to just deploy this on one machine with a small team of people, and then build up on that. And then if you see like, oh, this is actually working very nicely, it's a lot easier to scale that out, because with Kubernetes you need to, it's a bit more involved, shall we say, or you probably need to think way more ahead of time with that.
So what is the time between you making a decision that your DNS had to be containerized, had to be scalable, to solve this fastball issue, and now? It took you a month to create this setup, a year?
Because I have my code in Git. Let's see, so I started on February, and we're now, 2-3 months further. And most of my time was actually spent on getting the Ansible part working the way I wanted to. So everything else is just, all these things here, the AdGuard stuff. Once you've done a couple of these, it's pretty much copy and paste. Speaking of copy and paste, the equivalent problem, shall we say, in Kubernetes would be, I'm creating all these YAML files and I need to deploy them one by one or create them. So in Kubernetes, there's Helm to kind of like as a package manager, shall we say, to manage your applications. Nomad now has something called Nomad Packs, which is similar to have templated jobs. It needs some maturity, and personally I'm using Terraform to do the equivalent, shall we say, so I'm not really in the need to use that, but here my email, for my email at home I use Poste. It's also just, hey, this is my container, this is the mount point for the storage, couple of resources, done. Let's see, what else can I show? So I'm running console for the, let's see if I have it correctly, console.lan, for the, console. Yeah, here it is. So I'm using console for the service discovery. So for example, the way that my metrics collection works is that I have a Prometheus. So my Prometheus publishes its address to the cluster. So it's available here at 50.58 on port 9090. And let's see, my node exporters here. This is possible through this. So here, through this network stance, I say here, hey, you can find this service on static port 9100. And then I define a service. This service will register this container in the service discovery tool. So that means that it's available here into node exporters. And if I look at here, I can see all the instances of node exporters which are present. So if I ever deployed other machines next to this one, they will be discovered and listed here. And then Prometheus, dot on dot, I think it was 90, no, 9,000, wait, maybe I can take a Prometheus 9,000, 1990, yeah. Yeah, then status, service discovery, so these are the service discoveries, and here it can, can dynamically see that there are these node exporters present, and then it's going to scrape them. I have a problem with this. Need to fix that still, but yeah. I think I can, maybe, if I'm lucky. No, okay. So yeah, that's the presentation. Folks have any other questions? No? Okay. For me, my thing is that running containers in a clusterized way, this looks similar enough to if you're working with Docker on your laptop, or very easily, or very something doing very simple. This leans more towards what you're used to than if you would go for Kubernetes, for example, where you need to define a pod, and then all those other extra stuff, or you need a service, and you need to make sure that they are glued to each other, shall we say. So for me personally, this is a lot more easy than Kubernetes. All right. Thank you very much.
Zoveel fun at home thinking. Ja. De hand in hand gaan met uw werk. En nog wel wat. Nee. Ja, dat begint.
En plus nog een keer een plusdruk erop.
Nou ja, Nomad kan ik echt uitproberen. Ja. En dan uw Terraform gebruik je dan. Dus je gebruikt Ansible voor systemen op te zetten, ja. En uw Terraform voor gewoon...
Mijn jobs te deployen op
dat is niet...
Nomad.
Ja, dat zit niet mee in Nomad. Zo'n type jobs.
Nee. Voorgekoude dingen?
Ja.
Nee. Maar daarvoor zou je dan dingen kunnen gebruiken, die Nomad pack, maar ik gebruik dat persoonlijk.
Die mini-PC's dat je draait, ja. Dat zijn wat teamcentertjes Gen 7 of zoiets?
M74 of zoiets.
Ja, maar
ik heb wel één uitzondering, een HP...
Maar dat zijn gewoon quadcoortjes, maar 16 gram.
Ja.
Crystal.
Ja.
Hello.
Well,
ik heb een quiz meeting.
Oh, sorry. My name is Dr. Stosh. Should I leave? I just wanted to say it's no problem. I found something else that does actually.
Okay. Yeah.